Welcome to the technical study of Hamsat, the Indian amateur radio communication satellite, also known as VO-52. Hamsat was developed to provide satellite-based communication for amateur radio operators and to support education, experimentation, and technical learning. The satellite was successfully launched on 5 May 2005 using the PSLV-C6 launch vehicle from Sriharikota. Hamsat was launched along with Cartosat-1. Hamsat was a small communication satellite with an approximate mass of 42.5 kilograms. It operated in a polar, sun-synchronous type orbit at an average altitude of about 633 kilometers, with an orbital period of approximately 97 minutes. The major satellite subsystems include the power system, communication system, control system, telemetry system, and antenna system. Solar panels provide electrical energy, while batteries store energy for periods when sunlight is unavailable. The main communication payload consisted of 2 linear amateur radio transponders. These transponders received radio signals from ground stations and retransmitted them on another frequency. The basic communication process is simple. An amateur radio station sends an uplink signal to Hamsat. The satellite receives the signal through its antenna. The transponder processes and translates the signal to the downlink frequency. The transmitter then sends the signal back toward Earth, where another amateur radio station receives it. Hamsat used VHF and UHF amateur radio bands. Satellite motion also causes Doppler shift, so tracking and frequency correction are important during communication. The satellite supported long-distance amateur radio communication, education, antenna and propagation experiments, satellite tracking, and technical experimentation. The mission demonstrated how a small spacecraft can provide useful communication services while integrating RF communication, power, control, telemetry, and antenna technologies. Hamsat operated successfully for several years, and its operational service ended in 2014. Its contribution to amateur radio satellite communication and technical education remains significant. Future amateur radio satellites can use improved digital communication, efficient power management, advanced tracking, improved transponders, and smaller electronic systems. In conclusion, Hamsat is an important example of the application of satellite technology to amateur radio communication, education, experimentation, and international technical cooperation. Thank you.